Okay, you're given this implicitly defined function or relation as to find the first derivative, which will be a formula for slopes of tangent lines to the graph of that function. And you're told to use logarithmic differentiation. And that's usually what you have to do when you have a variable raised to an exponent that also contains a variable. So what we're going to do is take the natural log of both sides, and that allows us to use the power property of logarithms by moving these exponents down front. And that's what's happened on this line. And the natural log of e is just 1, so we can kind of ignore that factor and then start doing our implicit differentiation. So the derivative of x squared is 2x minus the derivative of y is y prime. Over on the right, we have to use the product rule. So we'll take the first function, 7x plus 8, times the derivative of the second. The derivative of ln of y is 1 over y, but then we have to apply the chain rule and multiply by the derivative of y, which is y prime. And then we have plus the second function, ln of y, times the derivative of the first. So now we've got to isolate y prime. My suggestion is to multiply every term by y to clear the equation of fractions. So this becomes 2xy minus yy prime equals, this y will cancel out if we multiply by y, and at the same time we can distribute the y prime. And there's y times this term. Okay, so now the idea is to collect all the terms containing y prime on one side of the equal sign. So these two are already on the right side. Picture transposing the negative y prime over here by adding it and then transposing the 7y ln of y to the left side, and you get 2xy minus 7y ln of y. Finally, factor out a y prime from each of these terms. You do get y prime times, well, this is what you get right here. And so if you divide the right side by 7x plus y plus 8, you will have a formula for slopes of tangent lines to the graph of this function. Now, here's what it looks like on Desmos. The red graph is the graph of the given function. Here's the derivative in terms of x and y. It's not so easy to locate points on this curve. I was able to get close to a point that lies on the curve when x is 2, y is about 1.139. You can see how close the left and the right sides are, within 4/100ths or so. But if I write the equation of the tangent line using point slope, y minus the y value of a sub 1 equals the slope times x minus the x coordinate of point A. And that does look like, indeed, we have a tangent line at that point. So I'm fairly confident that this is the correct formula for the derivative of y with respect to x. For that, this looks like it is a function. Passes the vertical line. Maybe not. There might be a relation, not a function. Okay, anyway, there you go. Hope that helped. If you have any questions, post a comment.